Hello, my name is Ms. Player, and this is part 2 of my two-part Excel tutorial video series, which is to show you how to make an appropriate graph for your DP Physics IA reports. If you don't know how to make appropriate data tables yet, then please first check out my part 1 video to learn those skills. I want to quickly point out two mistakes that I noticed in the part 1 video. The first is that the heading for the average period of one pendulum swing has a formula of t is equal to 10t over 10, not 10t over t as originally stated. The second is to show you the proof for how to calculate delta t squared. I don't know why, but the equation went wonky on Word when I tried to show it, so here's a screenshot of that proof. Pause the video if you need to look at it for longer. So you're going to want a graph that looks like this, with error bars for each data point, the best fit, maximum fit, and minimum fit lines with the appropriate linear equations and titled axes. Okay, so let's begin. So we have our raw and processed data from before. So what we want to do is we want to copy and paste the columns for the x-axis coordinates, which are the pendulum length. I'm just going to paste it down below here. Next to that, I want to copy and paste the values of the y-axis coordinates, which is the period of one pendulum swing squared. And next to it, I want to also copy and paste the uncertainty of the period squared. Okay, is it all there? 0.02, 4.13, okay. Looks all right. If by chance these copy and paste don't show up the way that you want it to because there's an equation, then you can go to select values only, and the numbers will preserve. Okay, I'm going to delete the equation here and here. Okay. So you're going to want to plot pendulum length versus t squared on a scatter graph. So I highlight those two columns, I go to Insert, Scatter. If by chance you see a series text box on the right here, please delete it. Okay, I'm going to reduce the size of the data point markers first. So to do that, I click on one point to highlight all the data points. I right-click, go to Format Data Series, click on the paint bucket symbol. I want to select Marker and Marker Options and Built-in and reduce the size to 2. Then go to Fill and click on Solid and select Black. Doesn't look like black showed up. What happened? Okay. Well, all right. It doesn't really matter. Okay, so you're going to want to plot the line of best fit. So again, click on one of the points so that all the points are highlighted. Right-click. Let me try that again. Okay, add trend line. It is a linear trend line. We are going to format the trend line. Got to display the equation on the chart. Then click on Paint Bucket. Click on Solid Line, and then Dash Type. Click the solid line and say reduce it down to 1 point and select black color. Okay. All right. Now, to add vertical error bars, I want to click on any one of those data points to highlight all the points. Then I want to go to Add Chart Element, select Error Bars, more error bar options. Okay, I want to go to Format Error Bars, Vertical, Both, Capped. It's not a fixed value, it's custom. So I select Custom, specify value, and then I want to select the delta t squared values for both positive and negative error values. Okay, do that again. Okay. To modify the horizontal error bars, I click on one of the horizontal error bars to highlight them all, and then I select fixed value and set it at 0.01 meters, which is 1 centimeter, since the fixed uncertainty of the pendulum length. Make sure that's both and that it's capped. Okay. All right, next up. We want to plot the maximum fit gradient line. So for the first data point, I'm just going to max right here. For the first data point, we want to add the x value uncertainty, in this case 0.01 meters, to the smallest value of L, which is 0.10 meters. So 0.10 plus 0.01 gives us 0.11. Now for the y value coordinate, you need to subtract the y value uncertainty, in this case delta t squared is equal to 0.01 seconds squared, and subtracted from the smallest t squared value of 0.45 seconds squared, this gives us a y coordinate of 0.44. Now for the last data point, I want to subtract the x value uncertainty, delta L, from the highest L value of 1 meter, which gives us an x coordinate of 0.99. And for the y value coordinate, you need to add the y value uncertainty. In this case, delta t squared equals 0.09. Added to the highest t squared value of 4.62 gives us a y coordinate of 4.71. Okay, so I click on the graph and right click and go to Select Data. I want to click on the plus symbol and name this series something like Max Gradient Line. And then for the x values, I highlight those. And for the y values, I do the same thing. Click and highlight the y coordinates and select OK. So I want to click on one of these points to highlight both data points. Right-click, Format Data Series. Click on the paint bucket. Select Marker, Marker Options, Built-in, Size 2, Solid Fill, and Black. Okay, hopefully that did it. Okay, that's orange. Okay, whatever. All right, so to plot the line of maximum fit, which is also linear, then you're going to want to click on that point again, so both points are highlighted. Format the trend line by adding trend line. You want to display the equation on chart. Click on the paint bucket. Select the dash type, which is solid, color, black, hopefully. Solid line, which is selected there, and then width of 1 point. Okay, let's just move this. So this is the maximum. This is the best. We'll fix those later. Now to plot the minimum fit gradient line for the first data point, you want to, let me label this really quick, For the first data point, you want to subtract the x value uncertainty, again fixed at 0.01 meters, from the smallest L value of 0.10 meters. So this gives us an x coordinate of 0.09. For the y value coordinate, you need to add the y value uncertainty, which is delta t squared, 0.01 to 0.45, and that gives us 0.46. Okay, for the last data point, you want to add the x value uncertainty, 0.01 to the highest value of 1 meter, which gives us an x coordinate of 1.01. And for the y value coordinate, you need to subtract the y value uncertainty of 0.09 from the highest value of t squared, 4.62, which gives us a y coordinate of 4.53. Okay, and similar to before, we click on the graph, right click, select data, click on the plus symbol, name this series something like minimum gradient line. Okay, for the x values, again, just like before, drag and drop. For the y values, same for the y coordinates, and OK. Okay, click on one of the points to highlight both points. Right click, format data series. Click on paint bucket, marker, marker options, built in, reduce to 2. I'm going to try to make it black, but who knows. Okay, X out. I don't know. Anyways, we click on one of those points again. So both points are highlighted. Right click, add trend line. It's linear. We want to display the equation. Then click on the paint bucket, dash type, solid, reduce to 1, and black. Okay. Okay, let's see, I've got 4.8, 4.6, and 4.4 for my gradients. I just want to make sure that they're in descending order for the gradients. So now I click on the chart. I go to chart design, add chart element, select grid lines, and select the minor horizontal and minor vertical. Okay, I also want to add X and Y axes titles. I'm going to delete the chart title because I'm going to label it on Word. So my X axes, let's see, add chart element, axes title, primary horizontal, and again, primary vertical. So my vertical is the period of pendulum swing. What I'm going to do is I'm going to come up here and copy this information. And paste it. Okay. And for my x-axis, that's length. I want the same level of detail as my headings. Okay. Now I can copy and paste my graph into my Word report, making sure there is an appropriately descriptive title above it. I'm going to drag the area of the graph so that it takes up most of the width of the page. I'm going to name these equations to match the fit line. So the highest gradient here is maximum gradient line. Now y is t squared, and x is L. This is my best fit line. Again, y is t squared, and x is L. And finally, this is my minimum. Okay, so all of my equations are there. I'm just being a perfectionist and trying to line them all up so that they're approximately the same place. Okay, sure, good enough. Okay, 4.8, 4.6, 4.4, good. Okay, and again, I'm being a perfectionist. I am going to change these to superscripts if I can. Nope. Okay. So there you have it. We are done. Of course, you will still need to complete all other aspects of the IA report, which is detailed in our report writing template. So please let me know if you have any questions.